Welcome back to Meaning from Data, Statistics Made Clear. In this lecture, we're going to face the big challenge of democracy, namely that the government responds to the will of the people. That's the basic concept of democracy. But the question is, what do we mean by the will of the people? Intuitively, the will of the people simply refers to the idea that we learn the opinions of everybody who's of the voters in the country, and we somehow put them together to make a statement about what the will of the whole society is. But we're going to see in this lecture and the next that that idea has some very serious inherent difficulties. Usually the will of the people is ascertained actually by voting. And in an election situation, what an election really does is to take the individual opinions of each of the voters and assembles them into a societal decision, the will of the people. So from a statistical point of view then, what an election actually is a summary of a set of data, namely the opinions of the individual voters. So in this lecture, we're going to consider two counterintuitive realities about the election process. The first one is that the voters' preferences about the candidates, which you think are going to be the only issue involved, turns out that their preferences sometimes have less to do with the outcome of an election than what voting method one uses to assemble these votes and make a summary. You see, whenever you have an election, you have to assemble the opinions and choose one winner. Well, okay, so that choice of method is going to be a primary issue. The second thing is that we're going to see a very unfortunate reality about voting methods, which is that every voting method has a very serious defect in it. And we will see what I mean by defects in voting methods, and that these are absolutely unavoidable. So these results about election processes actually give us a cautionary tale about what to expect when we summarize a collection of data. There are issues which these things will illustrate. So let's begin then with an election. Our election, the goal is to take the opinions, the choices of every single member of the voting population and return one societal choice. That's the goal of voting. And in an election, it accomplishes this by somehow putting those opinions together. And at first, when you think about this, it seems that there's nothing to discuss. What's there to discuss about voting? I mean, it's very simple. You ask people what their opinion is, and you count up the ballots, and whoever gets the most votes wins. It's simple. Why am I? It's a very short lecture today. That's the end of the lecture. But as a matter of fact, it turns out that we have many different methods of voting, and that voting method, the method of simply taking having everybody vote for one candidate and seeing who gets the most votes, that is the method called plurality voting. And it works completely perfectly if there are two candidates. Because if there are two candidates, whoever gets the more votes is the winner, and there's no question. The difficulties arrive when a third candidate arrives on the scene. When the third candidate wades into the election, the waters become very murky, very muddy. And I think the best way to start this whole discussion is just with an example. And so let's suppose that we have a committee in which there are three candidates. There are two Republican candidates and one Democratic candidate. And let's assume, just for the purposes of this illustration, that on this committee, all the Republicans only prefer Republican candidates over any Democratic candidates, and all the Democrats prefer the Democratic candidate over any Republican candidate. So this is just hypothetical, I know, but let's just assume this for the moment. So let's suppose that there are a few more Republicans on this committee than there are Democrats. And in order to actually specify our situation, let's just look at a specific chart here that illustrates the voters' preferences. So this table shows that there are 8 Republicans on the committee, and there are 3 candidates. The 3 candidates are Ron, Rick, and Dan. And the names are chosen so you can easily remember who are the Republicans and who are the Democrats. The ones beginning with R are the Republican candidates. The one beginning with D is the Democratic candidate. So the Republicans, of course, prefer the Republicans before they prefer the Democrat. The Democrat is in third place for all of these voters. So this number up here are the voters on the committee. So there are 8 Republicans who prefer Ron first, then Rick, and of course Dan, the Democrat's last place. And 4 of the Republicans on the committee prefer Rick, the Republican Rick over the Republican Ron and over Dan. And then there are 6 Democrats on the committee who prefer Dan, then Rick, then Ron. The other 4 Democrats, of course, prefer Dan. He's the Democrat. So they prefer Dan, then Ron, then Rick. You follow me? So this chart illustrates the preferences of the 22 people on the committee. 22 because there are, as you see, 8 plus 4, 12 Republicans, and 6 plus 4, that's 10 Democrats. Now, given these preferences, these opinions of the people on the committee, our question is very simple. Who should be declared the winner of the election among the 3 candidates, Ron, Rick, and Dan? Well, let's look at the chart and just see. The simplest way to evaluate the votes would simply be to use the plurality method. This was the method where you simply take the first place votes of each voter and you see who gets the most first place votes, and that person is declared to be the winner. So in this case, we have Ron got 8 votes here, and then Dan got 10 votes. You see? So Dan would be the winner because you see Rick only got 4 votes. You see only these 4 Republicans got. This is an example where the Republican vote was split. Even though the Republicans had 12 Republicans on the committee, since there were 2 Republicans running and 1 Democrat running, the Republican vote was split, and therefore the Democrat won this election. Okay. Well, let's see if there are different ways to evaluate the opinions of these committee members to come up with a societal opinion. Maybe Dan is not the best reflection of the true opinions of this committee. Well, here's another way. Here's an election method where you would have everybody vote for 2 candidates. They could just choose two people, so each person has 2 votes. And they get to vote for 2, and then we just see who gets the most of the votes under those circumstances. In order to count up how many votes each person gets, let's just look at, say, Ron. Well, Ron gets 8 votes here and 4 votes here for a total of 12 votes. All of the Republicans put Ron in first or second place. And then Ron gets 4 more votes from the Democrat, from this group of Democrats. They prefer Ron second over Rick. And so the total is 12 plus 4 is 16 votes in the vote for 2 method for Ron. Likewise, we can look at Rick. Well, look what happens to Rick. Rick gets, of course, the 12 Republican votes. They all put all the Republicans in first or second place. But Rick also gets 6 of these Democratic votes because he's in second place for 6 in the opinions of 6 Democrats. So he gets a total of 12 plus 6, which is 18 votes. Dan, notices, picks up no additional votes because the Republicans all put Dan in third place, and therefore they don't vote for him at all. Consequently, the effect is that under this voting scheme, Rick wins the election. Congratulations, Rick. That is a perfectly legitimate way to summarize the opinions of these 22 committee members and say that Rick seems like a good candidate as the winner. Well, we're not done yet. There's yet a third method for evaluating votes, and that's a way of actually weighting the opinions. In other words, giving 2 points for anybody who gets a first place vote, 1 point for getting a second place vote, and 0 points for getting a third place vote. You follow me? So this makes sense, that the person who's in first place should get some more a benefit from being the first choice rather than the second choice. And look what happens here. In this way of getting a weighted sum of the votes called the Borda count, the Borda count is named after a French scientist, Jean-Charles de Borda, who was one of the pioneers in the study of voting methods. The opinions change yet again, because let's look at, say, Ron's votes. He gets 8 first place votes, so that's 8 times 2, which is 16, plus he gets 4 second place votes here, so that's 4 more, that's a total of 20, and then he gets an additional 4 votes here for a total of 24. And there is his score, 24. In this case, though, Rick, let's see what happens to Rick. Rick gets only 4 first place votes, so that's 4 times 2, which is 8, plus 8 second place votes here, so that's 8 more. 8 plus 8 is 16, plus 6 votes here. 16 plus 6 is 22. So Rick gets 22 in the Borda count, and counting the same way, Dan gets 20 votes. In the Borda count method, then, Ron wins the election. Congratulations, Ron. Now notice what we have here. This is really quite interesting, because what we have shown is with the same preferences. We didn't change the opinions of the people. The people on the committee's preferences were given. There they are. They're on this list. And yet we just used 3 different reasonable methods for getting their votes and making one decision, and we got 3 different answers. All 3 of the candidates, from one point of view, should be viewed as the winner. Well, this is a troubling kind of issue. This is a troubling issue. And it's an example of a case where the method of voting has more to do with selecting the winner of the election than the preferences of the people. It turns out that a mathematician by the name of Donald Sari has proved a theorem that says that you can devise voting preference schemes like this chart up here, so that if you have any number of candidates, for example, you have 10 candidates, you can make it so that the plurality winner is one of the candidates. If you have a vote for 2 system, you get a different candidate. If you have a vote for 3 system, you get a different winner. I should have said, if you have a vote for 2 method, you have a different winner. You have a vote for 3 method, you have a different winner. You have a vote for 4 method, you have a different winner, all the way down to 9 different winners. And then if you have the Borda count, you get the 10th winner. So that every single one of those 10 candidates would win under these different voting schemes. Very interesting. Let's proceed then and investigate the question of runoffs. Because maybe that runoff elections would be the solution to our problems here. Why don't we just have a runoff? Suppose that you have because the runoff would have solved the problem here of electing a Republican at least. The problem with the plurality election in this previous example is that Dan, although he won the plurality vote, was really would have lost the election to either Rick or to Ron. So he was not in a way you could argue that Dan should certainly not have been the winner, even though he was the winner of the plurality method. But in a runoff, if there were runoff between 2 candidates, the Republican would have won because all the Republicans would have voted for the Republican candidate. But let's see a little difficulty with the concept of a runoff election. So here's an example where we have a different election situation. We have 31 Republicans and 25 Democrats in this voting population. So it's either think of it as a big committee of 56 people. And there are 5 people running for office. And again, we have the 2 Democrats whose names start with D and 3 Republicans whose names start with R. Suppose that the Republican vote is rather evenly split among their 3 candidates, and the Democratic vote is split rather evenly between their 2 candidates. Look what happens if we have a runoff. We take the top 2 vote getters, which are Dan and David. We have a runoff between Dan and David or Dan wins. We have a Democrat winning this contest. So let's say David would win the election. Of course, it would depend on how the Republicans voted in the runoff. But let's suppose that David was the eventual winner under this runoff scenario. Now look what happens if David does a little better job among his own constituency, among the Democrats. He does a better job. He gets more votes among the Democrats in the first election. In this case, the 25 Democrats vote 15 for David and 10 for Dan. In other words, he did better, right? David did better in that first election. Let's see what happens. Well, it's a runoff. Remember, who are the contestants in the runoff? The runoff are David and Rhonda. In the runoff, it's very clear who's going to win the runoff election, right? Namely, Rhonda. So Rhonda wins the runoff election because there are 31 Republicans who are going to vote for her and only 25 of Democrats who will vote for David. So the consequence of David's having done better in the preliminary trial was that he did worse overall. He lost the election. An interesting feature of the runoff kind of election, that doing better leads to a worse result in this example. That it can lead to a worse result, and it did in this example. Now, here's another method of voting that is called pairwise sequential voting. And this method of voting is a method by which you simply take 2 of the candidates and you pair them against each other, and whoever wins then goes against the next candidate. They go against each other, and then you get to the last candidate, they go against each other, and whoever wins at the end wins the election. Okay? Let's just see what happens if we have this election situation. Suppose we have 3 voters. So this is just a small committee. There are only 3 people who are going to vote. And they're going to make a decision among 4 different candidates. A, B, C, D are candidates that they're going to maybe appoint. Maybe it's a committee that's appointing an officer in a company. And this 3-person committee is choosing among 4 candidates. So the 4 candidates are A, B, C, D, and they decide to use the sequential pairwise voting method. So let's just see what happens. They first pair A against B. And you see, this could very well happen when you're trying to sift through candidates for this position. You may say, well, let's look at these 2. Which one of these 2 is better? And there's a discussion and an opinion is given. Well, so let's look at A against B. Well, voter 1 thinks that A is better than B. See, that's what this chart means. Voter 2 also thinks A is better than B. Voter 3 actually thinks B is better than A. But since 2 of them think A is better than B, A would win that first pairwise contest. So then we proceed and compare A to C. You can imagine this in a committee, right? You just go through the people and you say, well, let's see, oh, this one's better. Okay, we'll throw out B. Now we'll go on to C. Okay, so now let's look at A. A is still in the contest, and now A is being compared to C. So A goes against C. Voter 1 thinks A is better than C. Voter 2 thinks C is better than A. And likewise, voter 3 believes that C is better than A. So C wins the pairwise contest, and we proceed to see that now C beats A in this pairwise contest. Now C is the remaining candidate. We pair C to D, and look what happens. Here, D is better than C here, C is better than D here, but D is better than C here. So 2 of the people think D is better than C, and D beats C. So D would be the winner and would be selected and appointed to the board or to the position. Well, there's only one slight problem with this that is a rather major problem with this, and that is everyone likes B better than D. Look at this. Voter 1 thinks B is a better candidate than D. Voter 2 thinks B is a better candidate than D. Voter 3 thinks B is a better candidate than D. So this selection method has chosen a candidate as the winner where all people in the voting population think that one specific other candidate is superior. Isn't that a strange thing? Well, that is a rather unfortunate kind of a quality for a voting system to have, that it could choose a candidate when there's a consensus in the population that somebody else is the better candidate. Well, let's see now. We have then, actually, we've been discussing several kinds of properties that we might want in a voting system. One of them is consensus. If there is a consensus, we should go along with it. So one desirable property of a voting system would be that we want to go along with consensus. Another, unfortunately, the pairwise sequential voting system fails that method. Another quality that we would really like to have is the quality that better is better, meaning that if you do better, if more people want you and vote for you, prefer you in a higher position, then that should help the outcome. That should help you in the outcome, not hurt you. But remember that we saw in the case of the runoff elections that runoffs fail this property. Remember in the runoff, in the first instance where the vote was split between the 2 Democratic candidates, Dave and Dan, Dave went on to win the election because both of the candidates in the runoff were Democrats. Whereas when Dave did better in the preliminary vote, in the first vote, he did better, and consequently, the second place person was a Republican. And so in the runoff, he was running against a Republican, and therefore the Republican won, where in our scenario, there were more Republicans than Democrats in the voting population. So the runoff election fails this property that better is better. And that's a desirable property that we would want a voting system to have. The third question, the third desirable property that we would like a voting system to have is the idea that irrelevant is irrelevant. What I mean by that is that suppose that you have an election and there are several candidates, and then you throw out one of the losing candidates. You say you have a method of voting, you have an election, there's a winner, and then you discover after the election that one of the candidates maybe didn't qualify to be in the election, and you throw that person out. They lost anyway. Suppose it has the effect of making somebody else the winner. You see, that doesn't seem like a good quality for an election system to have. And yet, plurality voting has exactly that property, right? If you threw out a losing candidate, it can change the order of the winner and the loser. And this isn't just some abstract issue, by the way. In the year 2000, in the presidential election, there were 3 candidates, Bush, Gore, and Nader. Well, if Nader had not been in the election, Gore would have been the victor, right? Because Gore against Bush would have won, and certainly Gore against Nader would have won. Gore would have won the election. So the point is that in the plurality voting has the property that if you throw out a losing candidate, it may change the order of who wins the election. Of course, presidential elections are not decided using plurality voting of the popular vote. However, the 2000 election does give an example where eliminating a losing candidate would have changed the outcome. You might wonder why it is that I keep talking about all these methods that don't work. Why don't I just come out and tell you the one that has these nice, desirable features that we've identified? And the reason that I don't do that is, as you probably at this point have guessed, that it's impossible. There is no voting system that allows us to have all three of those properties in place. This is Arrow's impossibility theorem. It says that there is no system. Now, what is a voting system? A voting system means a method by which you take the preferences of all the people in the voting population and from them assemble a winner or an ordered list of the preferences, societal preferences. And what Arrow's impossibility theorem says is that there is no system for summarizing the opinions of people that satisfies all three of these conditions. Go along with consensus, which by the way is called the Pareto condition. Better is better, meaning that if a candidate does better, that should advance him or her in the outcome, the societal summary list, rather than decreasing that person's result. And irrelevant is irrelevant. If you throw out a losing candidate, it should not have the effect of changing the order of the other candidates. There is no system that has all three of these. Actually, that's not quite true. There is one system, and that is a dictatorship. If you just say there is one voter in the country, and whatever it is that that voter says goes, that does in fact satisfy all three of these conditions. One of the implications for Arrow's impossibility theorem is on the plus side. I've got to have at least a little ray of sunshine in this lecture. And that is that we never will have to worry that the bowl championship series method of evaluating the teams, college football teams, will be settled. We'll always be able to argue about them because we know that any method that they choose, no matter how many computers are involved or opinions of sports writers, no matter what method we use, one of those three conditions is not going to be met, and those issues will arise, and believe me, people will say, how could you possibly choose a voting method that fails to have go along with consensus, or where if you throw out this losing team that it changes the order? They will definitely bring those issues up. So that is a very cheerful thought that we can look forward to debates in the future. In the next lecture, we will continue this theme of the discussion of voting methods, and if possible, we will discover that in fact the situation gets even worse. This is not a happy lecture. Why am I giving these lectures? It gets worse. It gets worse, but it does have the implication that not only is it worse, but that you can apply the same analogous situations in many different statistical applications that have nothing to do with voting, and realize that statistical summaries entail significant problems. I'll look forward to seeing you next time.